So hi, my name is Sophie Wilkinson and I'm a postdoctoral fellow at McMaster University. And today I'm going to talk to you about our burning Boreal, in particular peatland wildfires in Canada. After a quick overview of what peatlands are, I'll discuss the process of how they burn, how this might change in the future, and how this affects our ability to live with wildfire. So the Boreal forest encircles the northern latitudes, mainly across Scandinavia, Russia, and Canada. And 28% of this global Boreal forest is situated within Canada. And this represents one of the largest contiguous forests left on Earth. The Boreal is a mosaic of different forest and ecosystem types, and a predominant but potentially undervalued ecosystem are peatlands. Canada has one of the biggest coverages of peatlands of any country, and here they cover around 1.1 million kilometers squared, which is equivalent to about 13% of our land area. On this map, you can see the greener areas are the peatland-dominated regions, and they extend up to the discontinuous permafrost in the Yukon and northern Alberta, and then all the way down to the US-Canada border in northern Ontario and across to Quebec. This map shows the areas of land that have burned since 1980. So that's just in the last 40 years. And you can see that this pattern tracks right along the Boreal, which is of course right through many peatland-dominated regions. So as Ed did, I would like to highlight that wildfire is an absolutely natural and necessary component of the Boreal, and it works to regenerate the ecosystems, which helps to maintain their health and their long-term carbon uptake. As fire moves through the landscape, peatlands experience fire too, and studies find that they actually burn at a very similar rate to upland forest stands, and in some regions this is around every 100 to 150 years, making it quite a regular fire cycle. But because peatlands are very different to upland stands, and they are the most carbon-rich ecosystems on the planet, how they interact with fire can have serious consequences for the total Boreal carbon sink, and also have impacts on our society and economy. So what are peatlands? Peatlands are actually a type of wetland, and there's many types of peatlands within this broad category. But a common feature of them is that they have this layer of peat just below their surface. Peat is partially decomposed organic matter. That is, it's the remains of vegetation that are undergoing incredibly slow decomposition. Decomposition of this organic material is so slow because the ecosystems are typically cold and wet, with a water table just below their ground surface. In northern regions, they're typically expansive, reaching as far as the eye can see, and these peatland complexes are made up of lots of different peatland types, some of which support dense trees and some of which don't. Most of these have been developing for over 8,000 years, since the last glacial period. One of the best peat-forming vegetation types is moss, and these mosses grow really slowly but continuously, and they get buried underground where they turn into peat, and they can store tons and tons of carbon in peat, which can be up to 10 meters deep. Because peat is such pure organic material, peatlands represent the densest carbon store of any ecosystem on Earth, and it's estimated that northern peatlands store over 400 gigatons of carbon. That's 5 times more than the Amazon rainforest. This is one reason why it's so important that we understand how they interact with fire, and also how this might change in the future. Recently, I worked with a team of illustrators at the National Geographic to put together these diagrams that help show the different types of peatland wildfires. The first is when fire moves through a healthy, wet peatland. Here on the left, the fire may just run along the surface and remove above ground shrubs and small trees like black spruce trees, which actually need the fire to spread their seeds for regeneration. In this case, we would say the fire is low intensity and low severity, with little carbon lost, and the peatland recovers quickly within a few years. The second is when fire occurs in a dry or heavily treed peatland, the peatland could have drained directly or indirectly by humans, or the region could be experiencing a drought, meaning that that peatland is drier than normal. And in this case, the top layers of the peat are exposed to fire. And after any trees have burned, this means that the fire can then move down into the peat profile, moving through the peat and consuming it, releasing the carbon as it goes. In this case, the fire is high intensity and the peatland is severely impacted, and suppression of these fires is extremely difficult. So this is an image of the Chuckegg Creek fire in 2019, and you might have seen similar fairly shocking images from other peatland-dominated region fires like the Slave Lake and the Fort McMurray fires. And these are examples where peatlands were in dry states and they actively enhanced these fires. The thing to remember here is that in healthy wet states, peatlands will act as fire breaks, slowing the spread of fire and sapping it of its energy. But in dry states, they can connect parts of the landscape and contribute to these mega fires. So when we move inside the fire, this is what it looks like. The fire front moves through the peatland, consuming all the above ground fine fuels like branches and needles, and then the fire is concentrated at the ground level. And you can see this here because this fire is burning in a peatland, and that peat is such a huge fuel source for the fire. After the flaming front has moved through, you're left with what we call smouldering combustion, and it's actually a fire within the peat deposits themselves. Smouldering is slow-moving, flameless combustion which produces smoke at the surface. And this is the most challenging part of peatland fires for wildfire managers and wildfire suppression efforts, because smouldering fire is really difficult to detect because it doesn't have those flames, and it can survive underground for weeks or months, and even over winter. Other than the direct carbon emissions, which add to national and global greenhouse gas emissions, the negative impacts of peat fires are all in relation to human society, communities, infrastructure, industry, as well as direct threats to human and health and well-being. Peat smouldering is a principal source of smoke and particulate matter emission, and this image actually shows an area of peatland that burned in the Fort McMurray fire that Stephanie will be discussing more later as well. And this shows the effect of the fire on the visibility on Highway 63. So this is the main evacuation route out of Fort McMurray, where 80,000 people were evacuated in just over 2 days. And the site that I studied was right between the lanes of the highway, just behind the smoke in this photo. If the smouldering fire continues to burn, it can burn right down through the peat profile until it's limited by either high water content or until the fire runs out of fuel, in this case peat. This peatland I studied burned with extreme severity, and the peatland was combusted right down to mineral soil in some places. We estimate that this peat was over 3,000 years old, and now all that old carbon is back in the atmosphere. Globally, peat fires contribute a significant proportion of anthropogenic emissions each year. And unfortunately, the combination of climate change drying out many peatland-rich areas and more people and infrastructure on our boreal landscape mean that peatland fires in Canada are predicted to become worse with more instances of this smouldering combustion. In addition to the potential impact on global climate, this will also impact local and national public health through smoke pollution, and could also cause the most severely burned peatlands to disappear from the landscape altogether due to something called ecosystem regime shifts. But there is hope, and that's what we're all holding on to right now, because luckily peatlands are incredibly resilient systems. And so far we find that they have an amazing ability to recover from even severe fire. In some peatlands, this is mainly due to a group of specially adapted mosses that are so good at holding on to water that they're actually resistant to fire. They act as an energy sink and help slow the spread of fire. These are called sphagnum mosses, and they often form in these mounds called hummocks. The orange colour that you can see in these photos is actually moss that has survived combustion by the fire. And the photo on the right was taken just hours after an experimental fire that I was involved in with the Canadian Forestry Service to gather more information about peatland fires and how to manage them. And amazingly, this sphagnum hummock survived whilst everything else around it burned. Some of my work now includes developing proactive management treatments using forestry techniques to help reduce the intensity and severity of peat fires, especially close to communities and infrastructure. In the long term, we're aiming to promote the growth of sphagnum mosses that will naturally reduce fire intensity and increase climate resilience for many years. This will be critical for us to understand how to live safely with wildfire in these regions and across Canada. So I hope that's given you a good overview of why you should care about peatlands, especially with respect to wildfire in Canada. So I will pass back to Ed now. Thank you.